Hello friends, welcome to JavaFx 3D tutorial. In this sub-series, we are talking about transformation. In the previous video, we learned about the basics of transformation, like we learned about the translate, rotate, shear and scale transformation. Now we will translate the object using the translate transformation. So here in the picture you can see there are 3 or 4 disks, and when we initially place them, the disk will be in the top right corner. So that's the default location, and it will be here in the origin, and the remaining portion of circle or disk will be hidden. So we'll be seeing only portion of the disk. Using the translate, here we will translate the circle, all the 4 circle, to a different location. Now let's dig into this video. In translate, all points representing the node is shifted to a new location. So whether it is a 2D object or 3D object, or we can say whether it is a rectangle or a box, the point that constitutes the shape will be shifted to a new location. So once the vertex points are shifted to a new location, obviously the object will translate to a new location. JavaFx provides translate class to perform 2D or 3D translation. So the class name is translate, which derives from transformation. And using this translate class, you can perform translation of object in 2D space as well as 3D space. Once the translate object is created, it can be added to nodes transformation queue via get transforms. So this means from the nodes, say for example, if you are creating a rectangle shape, from the rectangle shape itself, you can make a call to get transforms, and this will give you the collection, and to that collection you can add the instance of the translate class. So the translate class will be created for a specific shape, then you will add the translate to the nodes transforms collection. We can also use the translateX and translateY and translateZ properties to make the translation. That means here you will make use of the translateX, translateY, translateZ of the node itself. Say for example, in the rectangle object itself, you can make a call to set translateX, set translateY, set translateZ, and thereby you can perform the translation. In translation, the coordinate is shifted to new location, and node is drawn using the layoutX and layoutY property. So the coordinate itself, say for example, we will draw a picture for this. Once the objects are drawn, the coordinate moves to local space. So that means here we are talking about the coordinate. So JavaFx first moves the coordinate, then performs the drawing using layoutX and layoutY. After doing the drawing, it will move back to the local space. So usually these layoutX and layoutYs are useful to place the object on the scene. Once you place the object on the scene, then you can perform the translateX and translateY. So to clearly understand this, let's state that this is our local coordinate. And we will also assume that layout X for the object is set as 15 and layout Y is set as 10. And if you see, the object will be layout X 15, the initial object, it will be here. And layout Y is 10, right? So let's state like this: layout X is 15 and layout Y is 10. Usually it will be in the top corner, so here I drawn it in the reverse order. In JavaFx, coordinate will go like this: X, Y. This is the top corner, but for easy understanding purpose we will assume that it's in the bottom left corner. Alright, so layout X is 15 and layout Y is 10. So the rectangle will be drawn like this. We will also assume that layout X, I mean the translateX is 20 and translateY is 50. So what happens, let's state that this is the initial coordinate system. What JavaFx do is it will put the object in the initial placement 15, 10. Since it sees a translateX and translateY, it will shift the coordinate in X 15 and Y 50. Sorry, X 20. And if you see, this is the X shift of the coordinate system. This will be 20, and in Y we are shifting the coordinate to 50. So our new coordinate is located like this. So it's X, this is Y, or we can state X dash translated coordinate Y dash. So if you see here, the coordinate is shifted 50, 20, 50, 20, the coordinate is shifted. Then the object is drawn using the layout X and layout Y property. So what happens, from here the object will move to 20, then 50, and you can see the object is drawn in the shifted coordinate. So once the object is drawn, the coordinate will goes back to the original state, and you will see the object is translated from one location to another location. So JavaFx performs the complete coordinate transformation because it will be easy to perform the translation. So once the coordinate is translated, all it worries about is drawing the object using its layout X and layout Y property. And if you see here, the layout X is 15 in the translate coordinate and the layout Y is 10. And finally, after the transformation, you can see the object from this initial location is shifted to a new location. So this will be the original location. So that's how the translate will work. And if you see this 15, because we already have 15 here in the initial location itself, we are asking to perform the translation, and if you measure the translation, there will be 20 from the translated location, then there is a 50. So here itself it is 20, right? The object is translated 20, then there is a initial 15 that is also here. So 20 plus 15 is the offset, or from here if you measure, it will be exactly the translate what we asked. So that will be 20 here. And this initial offset is here previously, that's why the JavaFx uses the layoutX, layoutY after the transformation or after transforming the coordinate. So the sequence will go like this. When JavaFx reads the coding, when JavaFx walks through the properties, it initially sees layoutX and layoutY, so it places the object. Then it knows there is a translateX and translateY property set for a specific object. So for those objects, it will move the coordinate. So the shifted coordinate is the second task it will do. Then third, once again it will revisit the layoutX and layoutY, uses the translated coordinate and places the object again. And after performing this task, the coordinate will get back to the local coordinate system. So finally, in the local coordinate system, you will be seeing the translated object. Alright, that's all here. Now let's look at the code. So for this demo, we will create 4 circle object. And if you see, we just specify the circle radius as 20, 20, 20, 20, and we specify color for each circle. So there are 4 different color. After that, using the root pan, so root pan is not shown here in this demo. When we go to the coding, that time we will use anchor pan or some other pan. Then from that pan we are getting the children and making call to add all, and we are adding all our 4 circles here. And if you see here, we doesn't specify any layout X or layout Y property. That's why the object or the circle will be placed at 0, 0 location. Layout X is 0 and layout Y is also 0. So that means if this is the stage and 0, 0, this is the origin, and circle will be placed here, and what you will be seeing is half, 1/4 of the circle. This is what we are going to translate to a new location. In JavaFX, the coordinates will be like this, but in the picture, for understanding purpose, we kept it in the reverse way. That means in the lower left corner we placed the origin. Alright, now as I already told, if this is your stage, all 4 circles are placed in the corner. So this is your viewing area, and you will be seeing only one object, and each object overlaps on top of each other initially, because all will have same layout X, layout Y. That means layout X 0 and layout Y 0. So circle center will get aligned based on this layout X and layout Y. Next, we create a translate instance. And if you see, we are making use of the constructor translate, and translate 30, 30, that's what we are giving, and the object name is tran1. So we created the translate object, and then we are getting the get transforms method of the circle 1. So this will give the collection or the transform collection, and to that collection we are adding our transformation. Here the transformation is translate. So 30, 30 denotes in x coordinate we want to move 30, and in y we want to move 30. So that means we expect object to move here, and in the previous slide we saw how it will get performed. The transformation will be applied, the coordinate will be transformed, and layout X, layout Y is 0, 0. That's what we provide. So it performs circle or C1. For C1 only we are getting the transformation, right? That means the biscuit colored circle will move here and get located at this location. So the center of the circle will be at 30, 30. Next, if you see, the same way we create two more translate object, and this time we are translating 60, 60. In X we are translating 60, and in Y we are moving the object to 60 units. So C2, if you see transformation, we are retrieving from the node itself. Here C1.get transform, here C2.get transform. That means for one shape you can apply multiple transformation. So you can apply a translate, then you can apply rotate, shear, whatever you want you can apply for one object, and JavaFx will read all those transformations sequentially and applies that. So in this video we are talking about translate transformation, so we will concentrate on translate. For C2 object we applied the tran2. Tran2 is nothing but moving the object in x direction 60 and y direction 60. So we are moving it further 30 units, thereby we get 60 here and we get 60 here, and this will be our new location for circle, second circle. So likewise we perform translation for our third circle, and for fourth circle we will use a different method. So if you see in the circle itself, so this will be easy one. We are directly accessing the property C4 set translateX 120 C4.set translateX 120, C4.set translateY 120. Here what we are saying is move the object in x direction 120 and in y direction 120. In this case also the coordinate will be transformed, then object will be placed based on the layout X and layout Y. So this way here we translated all four circle from its initial corner to a different location. So now we will go to the demo and perform the transformation. So as part of the prerequisite, you know how to create a simple JavaFx application. Here for demo purpose I will be picking some of the Java file from our previous videos demo. So for example in JavaFx 2D we created some demo. We will just pick this file, copy, and we will place that here. So FX3D, we will call it as 05. So here we are using the 2D shapes again. Once we learn transformation, we will mixedly use 2D and 3D shape in the coming videos. So yeah, let's proceed. FX3D 05. translate transformation. So we just copied it and we will that's all. So the sample is ready quickly. So as part of prerequisite, we know that the entry point is main and it will in turn call the start method, and here we can define our scene graph relation. So in the start method, we will set up our primary stage and create 4 circles first. So first we create the root pen. So all this stuff we already learned previously: anchor pen, scene, JavaFx scene, and this is simply a 2D circle. JavaFx scene, paint. So for this color, there are 2 locations where we can use color. One is AWT and another one is from JavaFX part. So here we will use the paint color. Then circle is from scene shape circle. So at this stage, if we run this, alright, we will run our example. Just right click and choose run file, and you can see there is only one circle, and the maroon circle which was added last, so that it is overlapping all other circle. And there are actually 4 circles here at this location, but what you are seeing is only one circle because all shares the same layout X and layout Y. Now using the translate, we will move all these circle to different locations. So now we will go ahead with the second run code. Here, if you see, we are using the translate from transform javafx.scene.transform. The object is translate, and if you look at the translate syntax, it receives 2 parameters, double x and double y. X, the distance by which coordinate are translated in the x-axis direction, y, the distance in y-axis direction. So that's what this translate is representing. Once we create the translate object, we take the circle C1 and we retrieve get transform. So this will give us the transform collection, so observable list of transform, and using the add method, since we got the collection, we make a call to add and we supply this trans1. So when JavaFX is, so we already saw in run 1, the object was initially in the top left corner. Now since we have the transform here, the object will be moved to a new location. Now we will build this. So build is completed and we will run the file. And if you see, since it is overlapping all other object, this is the one which stays in the bottom that got moved to a new location. So the new location is 30 × 30. So the first circle got moved. Now we will move other two circle. So in the third run, we are performing a translation for C2 as well as C3, and if you see, we specify 60 cross 60, 90 cross 90. That means we are moving the circle diagonally. So we moved 3 circles. So by looking at the color, you can know this is biscuit, this is cadet blue and dark cyan, and finally we will move our maroon circle. So in our final run, we will use the translateX and Y properties. We will rebuild the solution here and run the file. So previously we saw maroon in the corner, right? Now it got moved all the way towards the bottom. So in the previous 3 circles, these 3 circles, we used the translate and get transform, and here we directly set the property translateX and translateY on the object. So here also we use the object only, object in the sense the node. For node we get the transform and we add the collection. We already talked about the base class for the transform, right? Translate, if you see, that derives from transform. So we add the translation for these 3 using the transform collection, but for 4th circle we use the property translateX and translateY. So the property name is translateX. Using the set translateX, we are setting that property to 120, and for Y we set 120. And finally we moved all our object from its initial layout X, layout Y position. Since we doesn't specify any layout X, layout Y, by default layout X and layout Y will be 0, 0, which is the origin, and the origin is in the top left corner of the local coordinate system. So when it is moving, what it does is, for example, for this 30, 30, it moves the local coordinate system to this location, then it reads the layout X and layout Y. Since we doesn't set any layout X, layout Y, it will be 0, 0. So circle will be drawn in the newly translated coordinate. Then second circle comes into picture. Once again, there will be a coordinate transformation from local to new location. The second circle is drawn. After drawing the circle, the coordinate returns back to the local coordinate space. Then the third coordinate translation happens, 90, 90. The circle is drawn. The same way, the other circle is also drawn here. That's all here in this video. Just now you saw the demo. Thank you for watching. Bye.